Have you ever stopped to wonder just how we manage to make our morning breakfast wobble exactly like a water balloon? It's a fun trick, but the ancestor of that jiggly stack looks completely different. If we rewind about 70,000 years to this excavation site in Iraq, archaeologists recently uncovered the charred remains of the very first batch. The recipe back then was purely about survival. Early humans would take starchy plants like ferns and cattails, grind them up into powder using heavy stones, mix in a little water, and bake the paste on a hot rock. They didn't spread the batter out wide and thin for the looks. When you flatten dough, heat penetrates it rapidly. It was a way to turn raw plants into quick, safe calories. For tens of thousands of years, our ancestors ate dense, heavy patties. Getting from those tough survival cakes to the light stacks we eat today required figuring out how to trap invisible air inside wet dough. Take the Dutch baby. It's a massive, bowl-shaped pancake that puffs up to incredible heights using only a blender and 0 rising powders. The trick is entirely in the temperature. You blend a thin batter of room-temperature milk and eggs and pour it into a blistering hot cast-iron skillet inside a 400-degree oven. The moment that batter hits the hot metal, the liquids inside evaporate into steam. Because the eggs form a flexible, stretchy web, that steam gets trapped, pushing the batter upward and inflating it like a balloon. But it relies completely on that intense heat. As soon as you open the oven door and the cool air hits, the steam cools and contracts, causing the whole structure to rapidly collapse into a crinkly, tender bowl. By using raw heat to trap and then release steam, cooks can temporarily manipulate the structure of the batter to create something airy and light. If you want a pancake that stays tall even after it leaves the pan, steam alone won't want. You need a mechanical approach, which brings us to the Japanese soufflé pancake. This technique revolves around a meringue. You carefully separate the egg whites from their yolks, then whip those whites at high speeds. The beating forces coiled proteins to unspool, forming a microscopic net that locks in millions of tiny air bubbles. You gently fold this foam into the ingredients and cook over very low heat, letting the dough set around the trapped air. Instead of relying on heat alone, chefs are physically building a microscopic net out of egg proteins to hold the air in place. Classic diner-style pancakes don't require whipping egg whites. They achieve their height through a quiet chemical reaction. To trigger it, you need 2 opposing ingredients, alkaline baking soda and a strongly acidic liquid like buttermilk. When baking soda meets buttermilk, they react, releasing carbon dioxide bubbles into the dough. But this neutralizes the acid, ruining the tangy flavor. We fix this with baking powder. It has its own built-in acid, generating extra bubbles while leaving the buttermilk's flavor untouched. Every time you cut into a thick buttermilk stack, you're eating the results of a controlled chemical reaction that bakes gas directly into the dough. All of these methods rely on eggs and dairy. So is it possible to trap air in a batter when you remove animal products entirely? You can still get a light texture using a mix of flour, almond milk, and oil. The lift here comes from a generous scoop of fresh baking powder. Resting the batter for 10 minutes allows the flour to fully hydrate. That brief pause also gives the baking powder time to begin generating microscopic gas bubbles before they hit the heat of the pan. By giving the chemistry time to work, you can simulate the structural lift of eggs and dairy, using only plants and pantry staples. We have moved far beyond that charred, 70,000-year-old survival food. We've learned to capture steam in a hot oven, weave mechanical protein nets, and spark chemical reactions in a bowl. We have spent centuries perfecting this science until these simple starches became part of global celebrations and historical community competitions. Mastering the physics of trapping invisible air transforms a dense survival staple into the light, airy food that defines breakfast today.